So today we're going to be looking at gravitational potential energy. Alright, and before we do that, we need to have a couple of little definitions of that, and we're going to do a couple of quick calculations, which should not take you too long at all. Right. Gravitational potential energy is an energy store that is associated with an object's height above a surface. So it's the energy stored due to an object's height above the surface. You can only ever have a gravitational potential energy inside a gravitational field. Right, so this is our definition of it. For this to happen, you need that gravitational field. Right. The heavier an object is, so the greater its mass, the more particles that are in it, the bigger the gravitational potential energy. Okay, so gravitational potential energy is dependent on two things. Right. One, the mass of the object. And two, the height above the surface of the object. Okay, we're going to look at a couple of quick little examples of this. All right. And the first one we're going to look at is we're going to just do a quick comparison of two objects that have a different mass but are at the same height. Okay, so we're going to have, this is our surface, which is going to be the Earth, and on Earth the gravitational field strength is 9.8 meters per second. So we're just going to put G is equal to 9.8 meters per second squared. And so there's a tiny little 2 above the S. Our first object, we're just going to colour in 4 of these squares, and then we're going to say that has a mass of 4 kilograms. So our mass is equal to 4 kg. For our second object, we're going to colour in just a single square, and we're going to say that object has a mass of 1 kilogram. If they're both held at the same height, 3 meters above the surface, which one will have a greater gravitational potential energy? Is it going to be this object, so we say A, or this object, B? It's going to be the object on the left, object A. It has the greater gravitational potential energy, because it has a greater mass, despite being at the same height. And all gravitational potential energy is just the energy stored when an object is above a surface. Now, we can calculate this by using a single equation, but this equation is a little bit tricky because it's got 3 parts to it. Okay, so the first part of our equation, I'm going to stick with this example to start with. So we're going to stick with this example as before, where we have our 4 kilogram object. That's 3 meters above the surface of the Earth. Right. Its mass is 4. It's 3 meters above the surface, so it's said to be at a height of 3 meters. And it has a gravitational field strength, the Earth does, of 9.8 meters per second squared. Alright, so what we're going to do is our gravitational potential energy, and now this is where things get a bit weird, we're going to write it as a big E with a tiny little g, so it's energy gravitational, is equal to our mass times by our height and times by our g. Okay, now because they're timesing, it doesn't matter which order you do it in. So we're just going to do our gravitational energy then is equal to 4 times by 3 times by 9.8. Now we're in physics, so we're allowed to use a calculator. In maths you're not allowed to, and Miss Ledingham and I have been chatting about it, and we would prefer it if you didn't, if you feel that you can do it anyway without a calculator. I'll just give you a second just to give you a chance to calculate that. The answer you get is 117.6. Right, now, because we're in physics, this 0.6, this 117.6, has a letter after it. And that letter for energy is joules. J stands for joules, and it is the unit we use for any type of energy. So be that kinetic energy, gravitational, elastic, doesn't matter, it's always the same. And that does say energy. Okay, now what we're going to do is we're going to do the 2 examples that are on your worksheet. The first one is about a bowling ball, so we're just going to write example 1. Now you're welcome to write out the question, and I would probably recommend you do. All right. A 5 kilogram bowling ball is held at a height of 1 meter. Above the ground. On Earth, the gravitational field strength, so I'm just going to put GFS, is equal to 10 meters per second squared. Sometimes in a question, they'll give you 10 instead of 9.8. Just use that number, okay? What is the gravitational potential energy? So it's telling us that we've got all of this information. Now, what we're going to do is we're going to set these out as our letters. So we're going to have M is our mass, and that is going to be 5 kilograms, because that's the mass of the bowling ball. G is our gravitational field strength, and that's 10 meters per second squared. H is our height, and that is 1 meter. So in this example, when we're trying to calculate the gravitational potential energy, the E little g, right, it's just going to be equal to M times G times H. Therefore, we're just going to put those numbers in the right places again, and we're going to do 5 times 10 times 1. Right. And that is equal to 50 joules. That's our answer for our first one. Now, we've done the first example, and I've just realised what I should now give you is the triangle. This triangle is slightly more complicated than normal, because instead of it having just 3 components, it has 4, okay? But it works in the same way that any other triangle does. All right, so we're just going to make a note of that. All right. So, as always, the things that we're timesing together go on the bottom, and the answer that we get is on the top. So this is going to be our E little g, and that's going to be our energy gravitational, or gravitational energy, or gravitational potential energy, and it is measured in joules. Then we're just going to put capital J. All right, we're going to have our mass, which is always measured in kilograms, and we get from kilograms, we get from grams to kilograms by dividing by 1,000. We have G, which is our gravitational field strength, or our GFS, as I'm going to write it down. And that will be given to you in the question. For those of you on the higher paper, you may get asked to calculate it instead. But that's just going to require you to rearrange these letters, and you can do that just by covering up whichever one you want. H is height, and it is measured in meters. So again, if you have it in centimeters, you need to convert it into meters, okay? And that can sometimes be an additional mark. I'd recommend pausing it and writing that triangle down, so then you get a chance to use it on the following question. Okay, we're going to do the second example now. All right, 300 gram robin, so it's 300 grams. That means we're going to need to do something to that. It's flying at a height of 2 meters. On Earth, the gravitational field strength again, so it's Earth. The GFS is equal to 10 meters per second squared. Calculate the GPE, or the gravitational potential energy. Alright, now this one here is only ever so slightly trickier than before. Again, we have our mass, we have our height, and we have our G. Our G is the same, which is 10 meters per second squared. Our height is 2 meters. Our mass this time is 300 grams. Now, just a second ago I said that we had to make sure that our mass is always in kilograms, so we need to convert from grams into kilograms. And to do that, you need to divide by 1,000. So 300 grams becomes 0.300 kilograms. All right, so let's just divide that by 1,000. Okay, and just make sure you note that difference, because this is something that most people trip up on. All right, the next thing we're going to do is we're just going to write out our equation that we're going to use. So our energy, G, is equal to M times by G times by H. And if you ever see this written, this is generally how it's going to be written, M times G times H. We're then just going to put the numbers in the right places. So we're just going to take our 0.3, because we've converted it from 300 as Rm, times by our G, which is 10, times by our height, which is 2. All right. And again, we just type that into a calculator, or if you're happy to do the mental maths yourself, you can. All right. Figure it out, calculate it, and then make sure you write out the units. So for this one, you should get an answer of 6 joules. And then that's it. That's your answer. Right. What I would like you to do now is for you to attempt the following questions that are on that worksheet. You have another 9 questions, and they should all be quite easy to do if you follow through those same steps. Right, and the steps are really simple. So the first one is just writing out that important information as you read it. The second one is getting the letters and the numbers lined up. The third one is what equation are you going to use. The fourth one is input your numbers. And the fifth one is just do the calculation. If you need any help, then please just leave a message on Google Classroom and I'll try and answer it.